Now, I hope all of you can see the first slide of atomic structure. Now, so in this chapter, I didn't start atomic structure in last class. Yes. Could you tell me what was the last topic which we discussed in our last class? Last topic. Tell me fast. Percentage purity. 1 minute, 1 minute, 1 minute. Oleum we discussed, right? Oleum thing we discussed, right? Okay. Then percentage labeling of oleum and H2O2 we did, right? H2O2 thing. Yes. Okay. So percentage oleum, H2O2 and equivalent concept. Those was the last topic of the chapter, and we discussed parallel equation also, right? PV equals to nRT, parallel equations, like assuming moles of one is forming X, then other will form similarly. And we discussed POAC, right? Principle of atomic conservation and all. Yes or no? So by this, mole concept is over. Let us start a new chapter, atomic structure. Now this chapter is how important this chapter in your coming exam. So the questions are being asked for in JEE mains, even advanced, in NEET, in KVPY, everywhere there is a one or two question from this chapter. Okay, now this chapter have a little part which will be done in physics also. So I would be discussing whatever is important for chemistry, and some places I will say you will learn in physics and I will skip that in chemistry. Okay, because the things will repeat, so there is no point of discussing the same thing two times. Now, sorry, this chapter is not coming up for the test, right? No, how? No, this chapter won't come for the test. Right now, the chapters which are coming is the some basic concept of chemistry. You do that properly. Introduction of atoms, Dalton's theory. We will see at Dalton's theory of an atom, cathode ray, discovery of electron, and property of cathode ray. Not just this, today we will be going to discuss anode ray also, and some other important experiments as well we are going to discuss. Okay, let us start with the first. As you all are aware of the Dalton's theory, before Dalton, who gave the idea of an atom? Any idea? Who was the scientist? Who was the scientist? Maharishi Kannad. After that, Democritus, yes, Greek philosopher. So Democritus gave the idea of an atom. Atom is indivisible thing. But a Greek meaning of atom is atom word came from the atomos, that is a Greek word which means indivisible. So Dalton took the then afterwards, after Democritus, the first person who gave the entire theory of chemistry is Dalton. John Dalton. Okay, he gave the he told that uh, atom is not divided and cannot be divided, and some postulates he has given which we have already discussed, right? And some people say that it was not like atomic particle. They started the word ultimate particle that become a atomic particle. Some theory says this also. Okay, so fine. Now here there is a matter main postulates of Dalton atomic theories. It is made up of a small indivisible particle, right? And now these are the postulates of Dalton. It is indivisible particle, cannot atoms cannot be created nor be destroyed during a chemical reaction. Just has a rearrangement, like N and H will rearrange themselves and form ammonia. This arrow has shifted backward. Ideally it should come on in between. Okay, so fine. So N2 plus H2 give 2NH3. That is a rearrangement of the atoms. No dear, I don't think they have asked on Dalton's atomic theory. Now number of nitrogen atoms 2. So number of hydrogen atoms is number of nitrogen atom 2, number of hydrogen atoms is equals to total number of atoms are 8. Means they will just arrange, like hydrogen and nitrogen will arrange themselves. On the left hand side these two molecules are there, on right hand side there is just ammonia. So the point is nitrogen and hydrogen are rearranging according to John Dalton. Then now, guys, next is matter is made up of indivisible particle called as atoms. Now, atom smallest particle of element which take part in chemical reaction. This is the third postulate. What was the third postulate? That it is an indivisible particle, right? And is the smallest particle which is taking part in a chemical reaction. Okay, fine. Then what was the other postulate? Atoms of the same element are identical in all respects. He said that, like, if you are taking the nitrogen, like N2 from two places, or let's say same element, like let's say hydrogen. So wherever you go, the hydrogen will be same. So atoms of same element will be identical in shape, size, and mass. Irrespective of the molecules, all the nitrogen atoms are identical to each other. They said no matter whatever NO2 is or N2 is or HNO3 or N2O5, nitrogen is same in all the case in terms of the size, shape, and mass. That was what his theory was. But now next theory was atoms of different element have different mass and size. Like N2 and H2 will always have the different size and mass. That was his theory. So mass of nitrogen and hydrogen and oxygen all will be different. This I already explained you when I started my basic concept of chemistry. So he said that different elements will have the different mass. Then he said the atom of different elements combine in a fixed ratio of small number to form the compound atoms called molecules. Okay, that atoms always combine in fixed whole number ratio, he said, to form compounds atom called molecules. Now we will see the some questions. Tell me answer of this question fast. I can create poll also, but polling will itself. Okay, tell me answer of this fast, fast, fast. Don't take much time. How I am getting mixed answers. In simple questions you can't make mistakes. Not allowed. Done? Okay. So 9 of you have given answer as B, and the correct answer is C. Very less number of very less number of students have answered C. Just 4. 11 gave wrong answer. 4 have given the C answer. Hey, John Dalton, atoms of all elements are aligned, including their masses. When did John Dalton said this? He didn't tell this.
So, but he didn't say B also, right?
In a given compound, the relative number of kinds of atoms are constant. Yes, relative number of constant means atoms always combine in fixed proportion. He said that thing.
Yeah. So I think it was a 6 to 7 point. Okay, yeah.
Sir,
Okay.
but isn't that law of constant proportion and wasn't it given by Lavoisier?
No, that is like atoms combine, but he said that atoms always combine in fixed, this whole number ratio thing. The last thing. Atoms of element combine in fixed ratio of small whole number to form compounds. This was given by him only. Fixed ratio. Okay, that is different thing, that in law of chemical combination we use this thing. Understood? Yes or no? In law of chemical combination, one law is this, that law of constant proportion. Got it? Got it? Okay, now, and according to him, there is a very small difference. He talked about this, that relative number and kind of atoms are constant. Kind of atom means like H2 is there, so all H2O will have same type of hydrogen. He said that thing. Wherever you go, hydrogen will remain same. Kind of atom remains same. But that is not true always. Ratio thing is true. Understood? Yes or no? Okay. John Dalton said atoms of same element will be alike, but atoms of different element will be different in all aspects.
So can you go back to the previous slide? Isn't that the same thing?
Which
Oh,
thing?
of all elements, like, sorry, sir.
He said all elements, that is wrong now.
Yeah.
He didn't say all elements are same. Okay, next. Fast. Okay, then most of you have given the answer C. I think that is correct answer. Okay, next. Fast. Poll. Sorry. I'll create a poll. Quickly answer this. Okay, 100% population is saying answer is C. Let's see whether they are right or wrong. So answer is C. Next. So now Dalton's concept of indivisibility of atom. Now there is some limitations. I told you John Dalton's theory was not true at all the places. So the concept of indivisibility of atom was completely discredited by a series of experiment evidences obtained by scientists. They said it is not correct, like indivisibility of atom thing. Because according to John Dalton, he said atom is indivisible, but later the J.J. Thomson and all the experiment he or the other scientists did some experiments and it was proved that atom is divisible. Okay, so what was that? So limitation of Dalton's atomic theory. It was proved that the atom is not divisible as an atom can be subdivided into electrons, protons and neutrons. That is different thing that later this electron, proton and neutron can be further divided. But they cannot be divided, but we know what are there inside this. Any doubt, guys? Any doubt in this? Hey, you people are not replying. Any doubt? No? Okay, fine. Next is it was proved that atom is not divisible as an atom can be subdivided into electron, proton and neutron. So atom can be divided into electron, proton. Remember that atom is tiniest particle that take part in chemical reaction. So here now he said the tiniest particle that take part in a chemical reaction. Okay, so particle in the sense is fine, but who will take part in a chemical reaction? That is electron, not the atom. Okay, next. According to John Dalton's atomic theory, atoms of an element are identical in mass, size, and many other chemical or physical processes. That is according to him. But practically, we know that there exist isotopes. Two isotopes have a different masses but same atomic number. So here also Dalton failed in explaining this. Any doubt? Yes or no?
So please could you go back to the previous slide? Should we note these facts down?
Limitations. Write it fast.
Yes, sir.
Means I won't be going to wait for a long time, just 10 15 seconds I'll give, Then I'll move to next slide. Who has annotated, please delete this.
So can you go to the next slide? I
Right.
mean the one after atom is not indivisible, that one.
Okay, 1 minute. Anyone who has annotated, please delete it. 1 minute. Can I delete it? Just a minute. Okay, fine, I've deleted. Yes, so which slide?
So the one after the slide that stated that it was proved that atoms are not indivisible. So the second limitation.
This is the first only. Second, I didn't give time to write. Means that's the second one. So atoms of identical shape in size, but this is the limitation. The discovery of isotopes proved that thing wrong. That atoms, according to this theory, atoms of same elements could be different. Is it clear? Write it down fast. Done. Once you finish it, write done. Okay, see, mostly all postulates were wrong only. Like, but atom combined in fixed proportion. That is one thing. Okay,
So if
otherwise,
all his postulates are wrong, then why are we giving so much importance to him, sir?
okay, because before this, without these postulates, you won't understand like how the research work was done, how the people thought about the other possibilities. John Dalton only said that, like, see, elements is nothing but arrangements of like atoms. Bond formation is during a chemical reaction, atoms are arranged. That is fine. Atoms are definitely arranged themselves. So, but you know that that was the time when people started working. So it is important to understand the Dalton's atomic theory or Dalton's postulate. No, no, this will not be tested in 10th July. Okay, I'm moving to the next. 10th July, whatever will be covered, whatever topics will be covered, you must have got the syllabus, right? For this chapter? Yes or no? Whatever will be covered, that could be asked in exam. Have I mentioned that this chapter in the syllabus? Did I mention that? Only some basic concept is written? Yes, no? So whatever is mentioned in the syllabus, that will be asked in the exam. Okay, I think you got the syllabus on WhatsApp. Now, next is, so you must have written this thing that isotopes has means elements, atoms of same element could be different as they can exist in isotopic form. So he said that two different elements differ in their mass and many other of physical properties. Is it true that all atoms are differ? All different elements have different mass. Is it true? No, it is not true. Isobars are the example. Like argon and calcium, both have mass 40. So both have the same mass. Yes, but their chemical and physical properties are different. That is right. So that part of postulate is right, that their chemical and physical properties are different, but their mass is not different. Understood? Any doubt? I'm moving to the next. Copy it fast in your own words. No need to copy the entire thing. Done? Yes, no? I am moving to the next. Now, according to his theory, when atoms of different elements combine in simple whole number ratios. Okay, fine. But if you see, like sugar, C12H22O11. Now, it is not a simple ratio, but you can see here they are combining in this type of ratio. It's not like 1:2 or 1:3:5. Not like that. 12:22:11. Okay. So this is one thing. Done. Any doubt in this? Could I move to next thing? Yes or no?
So how is 12:22:11 not a whole ratio? It's not simple, but it is a whole ratio, right?
Yes, not a simple ratio thing, but whole number is there. Yes.
Sir, what does simple mean?
Okay. I think that means like 1:2:3, something like that. One will come. Understood? Multiple.
Oh, it should be multiple. Okay, okay.
Okay. So okay. Now can I say that one of his postulates says that in the atom, smallest particle which is in a chemical reaction, the smallest particle that take part in a chemical reaction is an atom. Is this still considered as right? Yes or no? Smallest particle. Okay, I suppose electrons. Sir, shouldn't the smallest particle be electron? Particle. Okay, fine. Okay, if I ask you one question, like which postulates of Dalton atomic theory leads to help in giving the law of conservation of mass, what will be the answer? Yes. Which? The one postulate which says that relative number of atoms and kind of atoms are constant. Relative number of atoms and kind of atoms are constant in a given compound, right? So this means if they are constant, so in a chemical reaction mass will be conserved, right? And atoms cannot be created nor be destroyed is also right. Is it clear? Atom cannot be created nor be destroyed. That can also be telling you the law of conservation of mass. Got it? Why? Atom cannot, it in a chemical reaction, not in a nuclear reaction. I am talking about chemical reaction. Got it? Now, next is, so this is clear, I think. Dalton's atomic theory plans to explain the existence of allotropes. So here you see, his theory doesn't tell anything about the graphite, diamond, fullerene and all. These are the allotropic form of compound of carbon. Allotropes you learned in class 10th, right? So he doesn't tell anything about the allotropic form of carbon. Class 8th also. Okay. So this is a graphite, diamond, fluorine have a different structure, but all have the only one thing in common, that is carbon. They all are made up of carbon. So his theory doesn't tell anything about the structure. Okay, now question arises how these subatomic particles were discovered. Who discovered and which was the first subatomic particle which was discovered? Tell me fast. Electron was the first subatomic particle and J.J. Thomson discovered that. Now see, I want to tell you there were the two scientists who has a very important role to play. What is the role of William Crookes in this discovery of electron? Any idea? What is the role of William Crookes? No one talk about him. Everyone say J.J. Thomson, J.J. Thomson. Okay, fine. Actually, cathode ray was discovered in the Crookes tube. We say that the discharge tube was given by Crookes only, and he only found that the cathode ray is there in this or cathode ray is emerging when high voltage battery is applied over the low pressure gas. But the role of studying that gas is done by J.J. Thomson. Crook didn't you know uh, perform the experiment with those rays, but J.J. Thomson performed the experiment. He studied the rays and he gave the idea of electron. Is it clear to everyone? Yes or no? Study of cathode ray was done by J.J. Thomson, but William Crookes did the experiment. He found that there is a cathode ray emerging from cathode to anode, but he didn't study. Okay, so that is why it is written that William Crookes and J.J. Thomson studied various gases in gas discharge tube. Discharge tube is a glass tube with a very high potential applied to end of low pressure. Have you written this?
So should we write a whole slide or just the names?
No, just write the discharge tube thing, that a glass tube with a very high potential applied to its lower end is a discharge tube, and the two scientists' name, William Crookes and J.J. Thomson.
So do they ask
No
scientist
need,
names in
no,
JEE?
no one will ask. They have many important things to ask other than this.
So can it come in board level?
Yes,
They
in
also
fill in the
want.
fill in the blanks they will ask who discovered electron. You should write J.J. Thomson. Okay, I am moving to the next thing. Here you see cathode ray tube. This tube looks like this. Cathode ray experiment was done in this type of tube. Now what happened? They passed a very high voltage electricity through the end of these tubes, and a low pressure gas was kept inside this. Okay, just give me 1 second. 1 second, I'll explain you the entire thing. Just 1 second.
So
Sir,
could you
why
go
low-
back to the
low pressure
discharge
gas?
tube definition for a moment?
Pardon? You want me to show the definition one more time?
Yes, so for discharge tube.
Wait. Write it fast. Once you finish it, say done. Done, guys. Should I move to next? Yes or no? Okay. Now what all experiments were done by J.J. Thomson, I'll show this one small thing. I think you all can see this cathode ray tube which is in front of you as of now. Now see, this is the discharge tube. In this discharge tube, what all things were done? So here, okay, you see a very low pressure gas was taken. The reason of taking a very low pressure gas is a low pressure gas will help in conduction of electricity. Okay, very low pressure gas was taken, and the reason is when the low pressure gas, how it conducts electricity. Let's say low pressure gas, when kept in the high voltage, gas and gas molecules will strike together or collide together, or then what will happen, electron will be given out by those atoms. So what will happen, this will start conducting. So in this area we want a good conduction of electricity because it is a vacant space, only gas is present. So we need to take a very low pressure gas which will conduct electricity. Now what happened, when a low pressure gas, that is why we have a vacuum pump here. When the low pressure gas is taken in the tube and it is connected through a electrode, a very high voltage is applied. So what will happen, it was observed that some rays are emerging from cathode and going to the anode. Okay, and there is a one more way to detect the gas. What he did, he took the, you see here it is a fluorescent screen or fluorescent material. What is the fluorescent material? Fluorescent material is the material which glows when charged particle hits on this. So that tube will started glowing. Yes, ZNS was that. So that tube started glowing, or the inner part of the tube started glowing. This tells that there is a charged particle coming from cathode and going towards the anode. Okay, now this is a discharge tube and those rays were when so now what happened, if there is a ray which is coming from cathode and going towards the anode, the name of the ray was given as cathode ray. Now here you see the voltage is very low, voltage is very high. And now to study the gas, the major role of J.J. Thomson is he studied this gas. He did so many experiments, he performed so many experiments and found that what is happening with this rays. So one by one we will see the experiments which were done to observe this gas properly. Okay, so let us move to the next thing here.
Sir,
Yes,
sir, how do you decrease the pressure in a container?
by vacuum pump. Vacuum pump
Sir,
will take out the air.
sir, pressure is directly proportional to temperature, right?
Pressure is directly proportional to temperature, yes, if the moles are constant. If moles of gas will be reduced, then definitely pressure is not proportional to temperature. Got it?
Yes, sir.
Okay, next is, just a minute. Yes. So here you see almost high current electricity, that is 1000 volt, through a discharge tube at low pressure was applied. You can see that there is a glow. This electricity 1000 volt through discharge tube very low pressure. Glass begins to glow faintly. Okay, this glass begins to glow. As I told you, there is a rays which is going from one place to another and it started glowing. Now so the glow was due to bombardment of glass by certain kind of rays emerging from cathode. So there is a fluorescent material I told you. So there was a glow due to the bombardment of gas by a certain kind of bombardment of the glass by certain kind of ray emerging from cathode. This cathode is a negatively charged ray, that is why it is going towards the anode. Anode is positively charged plate of the battery. Okay, so this is what the glow due to, so the ray travels in a straight line until they strike the anode positive electrode. These rays were called as cathode ray. Please write it down fast, then I will move to the next thing. Guys, any doubt so far? Any doubt in this? Are you done with this? Could I move to next slide? So was there anode rays? I will come to anode rays, not now. Just wait for some time. Done? Guys, what will happen if I ask you one question? Let's say if they don't maintain the pressure, if the pressure is normal 1 atm like in room temperature, will there be a conduction? Will electricity flows through the tube? Answer is yes or no. Yes or no? Okay, the answer is no. I asked this question that if there is, I told you this thing, even if you put a very high voltage, but gas is not, the pressure of gas is not maintained, there will be no conduction. If pressure is 1 atm, let's say, and voltage is very high, even in that case there will be no conduction. No conduction, or in other word, no electricity. As I told you, to have the electricity we need to have a very low pressure gas. Okay, so when the discharge tube has been evacuated to a pressure of very less, let's say 10 mm of Hg, that how the pressure was decreased, 10 mm of Hg, a very low pressure. You know, the violet spark appear in the tube with the crackling noise. So you need to reduce the pressure like that. Then only the violet light will be visible with the crackling noise. The nature of discharge changes as the gas pressure in the tube is reduced. Okay? So nature of the discharge changes as the gas pressure in the tube is reduced. If you keep the pressure as 5 mm of Hg, let's say little more. If you reduce the pressure first here, if you take 10 mm of Hg, it will give you violet color. Okay, violet spark will appear. Violet spark appear. But if you reduce the pressure to 5 mm of Hg or little more, so the tube is filled with the luminous column. Tube is filled with the luminous column. Filled with the luminous column. Luminous column extending from anode to almost the cathode. Okay, so that luminous column is the positive column, or like the color of the light depends on the nature of gas in the tube. Fine, means as I am writing here violet color or anything, that depends on which gas you have taken. Let's say if you have a air, normal air, so color will be reddish. For normal air, color will be reddish. Bright red for the neon gas. Bright red.
So what pressure are we referring to here?
The
For me-
pressure inside the tube.
So what should its numerical
Okay,
value
now
be?
wait. Now one more thing. Let's say pressure is reduced to 0.01 mm of Hg. Let me finish this first. Let's say this will be reduced to 0.01 mm of Hg. What will happen? A very low pressure. What will happen?
So it look like a straight line, right?
Huh? Okay, fine.
It would look
The
like a straight
glow
line.
will disappear. Very good, Pratik. If you reduce the pressure to 0.001, the whole tube will become dark. Okay, so what will happen? Only there will be glow, whole tube become dark, only there will be glow. So we can write whole tube become dark, whole tube is dark. The only thing is there will be glow. What we can write? Only the walls of the tube towards the anode, only the walls of the tube towards anode, towards anode, towards anode or opposite to the cathode will glow. Towards anode, glow with bluish or greenish light. Glow with bluish or greenish light. Greenish light. Now what happened? Scientists conducted so many experiments. Okay, now why there was a glow? The glow was caused by the rays emanating from cathode and bombarding the glass wall opposite to it. Okay, so they named the ray as a cathode ray. Is it clear to everyone? Yes or no? Which compound was taken? Like zinc sulfide, one of the compound that is the used for the generation of this glow. Okay, did you understand little bit? I want to show you one small video of cathode ray thing. Just see little bit. I want to show one video to you. Just 1 second. 1 second. So see, what if the pressure is high, voltage is low? Nothing will happen, Aryan. Nothing will happen. I'm sharing one video in front of you. I think you must have seen this video earlier. If you have not seen, I want to show you this video now.
So today I'm at the University of Sydney with Dr. Phil Dooley, and we're talking about how our idea of the atom changed from a tiny little hard sphere to something more complicated. And this apparatus has something to do with that.
Exactly. It was quite a landmark historical experiment. It's just made of a tube of glass connected to a vacuum pump, and in the tube of glass there are two pieces of metal connected to a high voltage power supply.
So we can suck the air out of here.
That's right.
And then apply high voltage to two metal plates.
Yes. Okay. Normally with high voltage in air, we don't get anything except maybe a big spark. But what Geisler found, who did this in 1857, was something quite different. So shall we have a look?
Let's do it.
Okay, let's turn on the pump and the high volts. Turn off the lights so we can see what's going on. As you can see, something's happening now.
Yeah, I see a bit of a pink glow in there.
That's right. So imagine Geisler, the first person to ever see this. It's pretty surprising. That started people thinking, what is this stuff that's coming from the cathode? It seemed to be a ray emitted from this negatively charged one, which they called the cathodes, therefore it's called a cathode ray, and it became the topic for research for the next 40 years as all the big wigs of physics and science basically tried to work out what was going on.
So what did they figure out? I mean, what is going on? What's producing this glow here?
There were two main camps. One thought that it was waves, and the second thought that the electricity was being carried by a stream of charged particles. Over the next 40 years, they basically came to the conclusion, well, it was J.J. Thomson in 1897 who came up with the idea that there is a stream of very small charged particles, negatively charged. They're smaller than an atom. So the smallest atom, hydrogen atom, they're about 1,000th of the size of that. And it doesn't matter what material the metal is, it's always the same particle. So this particle appears to be in everything. This electron, as it was known, is what's carrying the electricity.
So Thomson came to the conclusion that all atoms have this particle as one of their constituents.
That's right. So it wasn't a billiard ball. There had to be something inside the billiard ball.
So how do I picture like a billiard ball with bits inside of it?
Well, you should probably think about a pudding.
A pudding?
Yeah, well,
Guys, did you understand little bit how the color was appeared? Got it? Okay, fine. Now I'm moving back
So
to
can you
the
repeat once, why do we need gas in the tube?
the point is, otherwise, okay, fine. If you try to understand, I will explain in a different way. Let's say if the gas is needed because let's say you have a helium gas or neon gas. Now when the neon particles will strike to the electron or neon, let's say neon strike to electron or some energy is given to the neon particle. So what will happen? This neon will gain the energy. Now this neon will run. This neon will run and it will strike to the next neon particle. If the pressure of gas will be low, these neons will have a little distance from them. Between them, there must be some different distance if the pressure is low. So due to, let's say, what happened once the neon will have a, let's say, electron strikes to this neon and remove an electron from neon. So what you will get? You will get the neon plus particle in that case, and electron will be generated in that case. So now what happened? This is the nothing but when the gas particle neon strikes to electron, it will become a cation, positively charged neon, and electron will be emitted out. Now this electron will acquire a velocity due to the potential difference. Now if there is a low pressure gas, this electron will get a time to speed up its velocity to before striking to the next neon particle. Then this electron will strike to next neon and it will emit the electron. Then next this electron will strike, or this Ne plus will strike to next atom and emit the electron, like that. So the point is, if you take a low pressure gas, this removal of electron will be easy because charged particle will acquire the velocity. Got it? So only these particles when give the electron, then only it will conduct the electricity, otherwise it won't. If you take the high pressure gas, so many neon particles are close to each other, they won't get the enough velocity, enough speed to chuck out the electron from the other neon atom. Got it?
So the motion is seized.
Motion is not seized. Motion is not sufficient to take up the electron. That is why the gas is still in motion, but it is not conducting. It is not a conducting gas. Understood? Raghav, clear? I'm removing this.
Yes, sir.
Okay.
So can you just wait for 1 minute so I can write?
Write in your own words. Got it?
Yes, sir. I'm writing in own words.
So here you can see this glow. This glow, I have told you at different pressures, this glow will vary. And the ray of electron we also observed. Sometimes when you decrease the pressure with very low amount, there will be no glow at all. Just the glow will be there near to the cathode. Okay, near to the cathode. Let us do this some questions. But before going to questions, if anyone has any doubt, in this page, then please ask. Otherwise, I'll move to the next thing. I will discuss about the experiments. So here you see a very low pressure gas was used. We will see the pressure value. We have already seen the pressure value, and see here the pressure value I have already showed you, 10 to the power minus 4 atm. That is what you have written, right? So this is a very, very, very low pressure gas.
So can you convert that to mmHg?
Mm of Hg.
Yeah.
So 1 mm of 1 atm is 760 mm of Hg. Let's say 1000 mm of Hg. So 10 to the power minus 4 is almost 0.1 or lesser than that, right? Got it?
Sir, but you said that at 0.1 mmHg nothing will happen, right?
Who said nothing will happen? I said 0.1 mm, everything will be dark, but at the end of near to the cathode, near to the anode, there will be glow. You have written now?
Oh yeah, yes.
What you have written? When the temperature pressure is so much low, that is around this mm of Hg, whole tube will be dark. Only the walls of tube towards the anode glow with the bluish or greenish light. Got it? Though the light is depending on the nature of the gas. But did you get little bit about this? Yes or no? Any doubt? No doubt? Sir, how did they find? Sadhna, you need to wait for some time to know the answer of this question. Any other doubt? Yes, it will work for any gas. He did experiments with so many gases. Okay, now I already explained you this part. This ray is called as cathode ray. Now these ray travels in a straight line until they strike to the anode surface, positive electrode. So we will do that. We will see what experiments were done to predict that why this travels in a straight line. Before that, please answer these questions fast. What is answer of this? Yes, you write the answers. Write it fast. I think most of you have already answered. Okay, just answer this. Next question I will give poll. Most of you have given answer. Answer is A. Any doubt? Yes? Next. Now here you see J.J. Thomson showed that the rays were deflected away the negatively charged plate on application of electric field. So here you see when the electric field was applied, the ray deflected. Okay? What happened? You see there is a discharge tube. This is the discharge tube. This is the cathode. This is the anode. Something is there. And now the rays which are passing, there is a one more electric field was applied perpendicular to this rays. Right now rays are traveling like this. Let's say rays are traveling like this. From this hole, there is a one hole you can see here. So he made one hole, the rays are traveling like this, and on the perpendicular plane he put two plates. On the perpendicular plane he put two plates. If one is the positive terminal of the battery and another is the negative terminal of battery. To check the charge on the particle, he put these plates like this, and he observed that these ray got deflected towards upside. How he got to know that? He put again fluorescence material on the inner wall of this thing, and it started glowing. This inner wall of this tube started glowing. This means there is a deflection towards upside, towards the positive plate of the perpendicular electric field. Did you understand? That was the first time it was proved that it is a negatively charged particle. Any doubt? Yes. Again I am repeating. 1 minute. This will give you little more clarity. So here you see cathode ray. This is the cathode, this is anode. There is a perforated anode. Perforated anode means there is a hole in anode. So when these rays were passed, there is a perpendicular, on the perpendicular plane, one more electric field was applied. So these rays were deflected towards upside in presence of this electric field. Understood? This tells the presence of negatively charged particle in this cathode ray. Why he named it as a cathode ray? Because it emerges from cathode and going towards the anode. So he named this gas as cathode ray, or this ray as cathode ray. But it is deflecting towards the positive plate of the perpendicular electric field. Is it clear? So, but since electrons were not discovered and they did not know the electric field has electrons, then how they did know that No. Electrons were not discovered, but it was discovered that opposite charged particle attracts towards each other. So when electric field was applied, when voltage difference was applied, electric field is nothing but voltage difference. And that voltage difference told that all these rays were moving towards the positive plate. This means these rays are negatively charged. I am not saying these rays are electron. Understood? Any doubt? Okay. Sir, can you previous slide, 1 minute? I'll go to previous slide. Any other doubt? Current. Um, yes, movement of electron. Raghav, I need to check that thing. But you know, voltage difference thing was earlier there. So due voltage difference, voltage difference is there. This means that the opposite charge, like let's say positive charge is there, so it will move towards the negative plate. Negative charge is there, it will move towards positive plate. It was charge species were known at that time. It was not known that, let's say, you can't say that atom has a charge or not. That was not known, but voltage difference could be applied at that time also. This means electricity was discovered earlier only. So you can check that thing. I think definitely electricity and current was discovered earlier, because why I'm saying this, because electrochemistry came after discovery of electricity. And after discovery of electricity, if electrochemistry came, and then only so many experiments were done. So I think it means before this experiment only current was discovered. Understood? Yes. So this is just what I'm correlating the electrochemistry and all. That's why I'm telling. But exact year you will get to know in internet. You can check. Understood? Okay. So 1808. Okay, fine. So I think it was long back, right? So now conclusion. So here you see. So J.J. Thomson deflected the rays of particles using the electric field. So these results were found to be identical. Now for whatever gas taken, these results were identical. Okay, whatever gas taken, gas was deflected towards the one direction. So conclusion: cathode ray were the stream of fast moving negative charge particle called as electron. Understood? Yes or no? Please write it fast. Understood? Now see, since you have asked the year, I'll tell you. You know, they have written the stony word, that one scientist named John Stone Stoney. He found that electricity in 1874 only. An English scientist concluded that the electricity exists in discrete unit, and that the unit are associated with atom. What was his finding? Means electricity exists in discrete unit. And before that, Mr. Faraday told, like, he found that you can deposit a silver metal by passing the electricity through the silver chloride thing. So this means that if atom can be produced by passing electricity, this means atom must has a electron component in it. So that were the earlier, findings before this experiment only. So Faraday finding indicates that atom had an electrical nature, because Faraday told that if you pass 1 mole of electricity, it will give you 1 kg of hydrogen from water. So this means if you are getting hydrogen by passing electricity, definitely there must be electron component. So Faraday finding gives the indicated that atom has the electrical nature. Then Johnston Stoney also concluded in 1874 that electricity exists in discrete units, and that units are associated with atoms. Okay, that is why he suggested the name electron for the postulated unit of electricity. Okay, now, but experimental proof of existence of electron came later. Is it clear, Raghav? Or those who have doubt about the year and the discovery year and all those things? This is the experimental proof of electron thing. That came very late after discovery of this electric field, electricity and current and all. Got it? Yes, no? Any doubt? Hey, why you are not replying? Any doubt? Now, next is this cathode ray discovery of electron. He also calculated the velocity and specific charge of electron. Specific charge is charge by mass ratio. That is E by M. So he calculated the E by M. Please copy it down fast. Then I'll move to next. Understood?
So he here is Thomson, right?
Huh? It was done by J.J. Thomson only. Okay. Guys, one more question. The neon lights which we see, the neon lights or the fluorescent light bulbs, are they a kind of discharge tubes? What we have discussed in cathode ray experiment. They also glows. They also have some colors. Are they the same type? Like discharge tube we discussed. Again I am repeating. This photo if you have seen, I have added one photo. This photo. Are they the same thing like what happens in a discharge tube? A high voltage and low pressure gas is filled in it. And when electricity is passed, they glows. So it is the same thing. So neon signs, fluorescent light bulbs, television pictures, tubes are all the example of discharge tubes where gas is there, voltage is applied, vacuum is there, it will glow. I hope you understood. Yes? Now, so quickly answer this question. Okay, now wait, I'll come to this. So this E by M ratio is clear. Guys, now yes, wherever there is a glow, like there is a gas filled in it, so it is act like a discharge tube only. Because gas can allow the electricity conduction only when it is put in low pressure, and the mechanism is similar like what we discussed in discharge tube. Understood? So in LED also I think the same thing. Okay, now E by M ratio. Can you see this? Cathode and anode, cathode to anode ray is going, but anode is having a hole, so with this ray will pass through this. And later magnetic field is applied. When the magnetic field was applied, the ray will get deflected. When the electric field was applied, ray will get deflected in another direction. And when there is no field, electric field or magnetic field, the ray pass in a straight line. Did you understand? Yes or no? Have you written that E by M ratio was found to be same for all the gases? Yes or no? Yes or no? Okay. Why is the same? Because all the atoms will give electron only. the example I gave you for neon, let's say. So neon, when give the electron, it will form neon plus and electron, it is constituting the cathode ray. Similarly, let's say you have a helium gas. Well, helium will give the ion, it will form He plus and electron. This will form the cathode ray. So did you understand? Both are giving E and E only. So the charge of this particle of cathode is E by mass of E. Both are same in both the gases. Understood? Yes or no? So E by M ratio is same. Okay, done?
Sir, could you explain how it is same again?
What? Let's say neon gas is taken. So neon gas will generate electron like this when it loses the electron. Helium gas is taken, helium will generate electron like this. And since I told you, when gas is taken, negative part of gas will be a part of cathode ray. So negative part is acting like a cathode ray, and negative particle has same thing in both the gases. No matter what gas you are taking, the negative particle is nothing but the electron only. So if electron, and now what does this mean? Neon is giving Ne plus and E. Helium is giving He plus and E. This means one type of particle is same in both the gases, that is E. So charge of E by mass of E will remain same in any gas, because one particle will always have the same charge and same mass. Understood?
Yes, sir.
Okay. Now these particles will constitute which ray? After some time I will tell that. But these particles will form which ray? These will form the anode ray. Because one is the cathode ray, another will be the anode ray. Will I say that charge particle E by M ratio of anode ray will also be same for different gases? Can I say E by M is same? E means charge by mass ratio I am talking about. Will the charge upon mass remain same? Charge may be same, plus 1 in both the cases. But is mass of neon ion and helium ion is same? Mass is not same. So specific charge ratio is not same for anode ray, but specific charge ratio is same for the cathode ray. Understood? Yes or no? So E by M ratio was same to be found for all the gases, is same for all the gases for the cathode ray. Got it? Have you copied this? Yes or no? Yes? Okay. Next is, sir, what are we taking such an expression of E by M in first place? I didn't understand what you are asking, Kaustav. Could you explain? Could you unmute your mic and ask?
So why are we taking it exactly to be E by M, like specifically E by M in the first place? Like why?
No, it was the charge by mass ratio only, but charge is E minus, that is electron only. So charge of electron by mass of electron. Charge of electron is represented by E, that is why I am writing E.
So no, so why are we taking this, like why are we taking this combination of the formula itself like that?
Okay, no, see, specific charge ratio is a term given. Are you having doubt in this? Why we are saying it is a specific charge?
So yes, sir.
So specific charge ratio, actually what happened, at that time we have no idea what the mass of electron is, what the charge of electron is. Before this experiment, no one has an idea about the mass and charge. So one ratio was calculated, that was the charge by mass ratio, and which was found to be same for all the gases in cathode ray. So that term was named as specific charge ratio, because both things were unknown to us, even charge also and mass also. Understood? So E by M was calculated, and that is the specific charge. Later E and M was calculated after this experiment. First they calculated E by M ratio using this experiment. Understood?
Yes, sir.
Okay. I hope everyone has copied this. Let me move to the next thing. So now see, this is the E by M ratio. So here E by M ratio was found by the J.J. Thomson, that is minus 1.758 into 10 power 11. Please copy it down fast. This is E by M ratio for all the gases in for cathode ray.
So do we need to
Now
remember all the
wait. Now E by M is constant for all the gases. This means the particle in cathode ray is a fundamental particle. Fundamental particle means whose nature remains same for all the gases. Yes, tell me, what is your doubt?
So is it necessary to remember all the significant digits or just
No
first
need to
three
remember.
are?
No need to remember significant digit, and even I won't recommend to remember E by M ratio. But later I will recommend to remember E separately, M separately. Charge on electron and mass of electron you need to remember. No need to remember the ratio. Just write it.
Done, sir.
Again, I am repeating, the electricity was discovered long back. Current was discovered long back before this experiment. Because in early 19th century it was discovered, electricity thing. This came after half of this 19th century, in second half. Okay, so all these experiments were easy to be conducted, but mass and charge of electron were unknown at that time also. Okay, then next is charge on each electron measured by millikan. No, the concept of electron was there, but the name, that name, you can say that in early 1874 only the electricity exists in different thing was given. So name was suggested, but the charge on electron was not calculated earlier, neither mass. Understood? Now, charge on each electron measured by millikan. Now see, today we will see the millikan oil drop experiment in few minutes, or might be in second half of the class. We will discuss the Millikan oil drop experiment. There we will see how we calculated charge. But once we calculated the charge using the Millikan oil drop experiment, can you calculate mass of electron also? Yes or no? So please remember this as a mass of electron. So what you need to remember, charge on electron 1.6 into 10 per minus 19 coulomb, and mass of electron is 9.1 into 10 power minus 31 kg. Just two significant figure is fine. In charge of electron, remember four significant figure 1.602. Most of the time 2 is sufficient. 99% times just 2 is sufficient. Minus 1.6 thing. Hope you understood this. Could I move to next? Done? Okay, next. Sir, what does the magnitude of negative charge means? Okay, so charge on electron, because electron is a negatively charged atom, or the cathode ray is negatively charged atom, cathode ray is negatively charged ray. So, and its smallest unit is the electron. So definitely it will have a negative charge. That is why minus 1.602. For proton it will be plus 1.602. Rest everything remains same. Got it? So it is just tell the relative thing, relative terminology. Sir, what does magnitude of it means? Magnitude. Magnitude of this means that one electron has this much coulomb charge. The smallest unit of any charge is electron, and that is having this much coulomb. Got it? 1 coulomb is very high, very big unit. So charge on 1 electron is this much coulomb. Got it? I'll move to the next thing now. Okay. Tell me answer of this fast. A, all of you are saying A. Very good. Next. Fast. Done.
So, sir, I had one question. How did J.J. Thomson directly calculate the the specific charge without knowing the mass as well as the charge?
Oh, sorry, I was muted. Sorry. Am I audible now? So to answer this question, here what he knew that the how much electric field he has applied, and he knew about the velocity of the beam which was observed. Understood? When he used the magnetic field also, he found the angle with which beam is rotating. So all those things were considered to calculate the E by M. Got it?
So he sort of indirectly measured it.
Yes.
Okay, yes.
Now, okay. So is it clear till here? Yes or no? Okay. Now, next is yes, electron need medium to travel, not electromagnetic radiation. Means, oh, okay. Electron needs the medium to travel. Okay, next is stream of this. Yes, what is answer of this? Done. Okay, uh, answer is A for this. I hope you understood this part. Like one question the Zayan has asked the E by M thing. This experiment, you know what he did? In one case it is striking to B. What he did, he kept the electric field and magnetic field such that these rays are not diverting to any angle, and using those two values of electric and magnetic field he calculated the A by M ratio. Understood? There is a one ray which is not diverted in any direction due to the variation of electric and magnetic field. So, sir, so are they rays splitting? Splitting means one ray is coming. If you apply only electric field or magnetic, you know what is happening? By different electric and magnetic field, these rays are diverting. Let's say electric field dominates, then these ray goes towards upward direction. If magnetic field dominates, this reaction goes towards the downward direction. But he adjusted the electric and magnetic field such that these rays go straight and hit to this surface without diverting. Got it? Yes or no? So by that thing he calculated E by M ratio. Understood? And he found that E by M ratio remains same for all the gases. Understood? Now, who gave those cathode ray particle? Cathode gave or gas gave? A very interesting question. The cathode ray particles were given by cathode or by gas? Very good. Those were given by gas, not by cathode. Many people have the confusion, sir, these electrons are going from cathode, coming from cathode. No, these are given by gas. Different gases give different electron. Is it clear to everyone? Yes or no? Now, so another properties of cathode ray, it travels with a high velocity on a straight path. You know what was done by the J.J. Thomson? He kept one metal plate, one metal object, and again the phosphorescent screen or fluorescent screen is there at the back. So he found that exactly a shadow of the object is observed. This means rays are traveling in a straight line. Then only they will create an exact shadow. Please write it fast. Done? Done? Color is because of the gas present in it. Kaustuv, clear? Different gases. That is not because that is a charged ions of gas. Got it? Sir, actually even that we will come to that fan thing. Understood? I am moving to the next. I hope you understood this. Next. So this is about the shadow of an object in the path. Now what is the properties of cathode ray? Here you see cathode ray produce a mechanical effect. He put one, you can say one spinner type of thing or a paddle type of thing. So that paddle started rotating by the ray. This means electrons have some mass and momentum. Then only they can exert the pressure. This means these are particles of matter. Electrons are particles of matter. So cathode ray produce a mechanical effect on a small paddle placed in the electrodes. Which paddle? This paddle. Got it? So you can write it this fast. Done. Done. Okay, I said this pedal is placed in this path where the cathode rays run means are appearing. So this pedal has started rotating. This means cathode ray can exert the force on pedal so that pedal can rotate. Got it? Yes or no? Okay, next. Properties of cathode ray. If electric and magnetic field are applied cathode rays in a discharge tube, the ray are deflected, thus stabilizing that they consist of negatively charged particle. Any doubt in this, guys? Any doubt in this, then please let me know. No? Okay, fine. I'm moving to the next thing. Have you copied? So now when electric and magnetic field are applied in cathode ray and discharge tube, deflection of cathode ray in presence of this establishes they are charged. Because of this movement of the ray in one direction tells that they are charged, and deflection away from the negative plate in electric plates. You can see here electric field. There is a positive plate, negative plate. But when the ray was passed in presence of electric field, it was striking at point A to the fluorescent screen. Electron's beam was struck at electron beams was reported at this point A. This means the beam of the cathode ray is nothing but negatively charged. Guys, clear? Could I move to next thing? Yes or no? Copy it fast. Done.
So there was one question in my mind.
Yes.
Deflection away from negatively charged electric plates established they are negatively charged. So we are saying that like charge is repelled, right? We are using that property. So how did they know that that property existed at that point in time?
That is what I told you. It is like the negatively charged thing and positively charged thing were not unknown at that time. They didn't prove that atom has the negatively charged or positively charged thing. Electron was proved for first time there only. But they got to know that if electric field is applied, this rays is moving towards the point A. This means that ray must have a negative charge. Understood?
Yes, sir.
But earlier it was not proved that atom is having an electron or proton. Though that is what I explained you earlier. You know,
Yes, sir.
the experiments electrochemistry was introduced way before this experiment. Okay, so that time people have the idea, okay, it will deflect. Electric field, magnetic field will deflect the means if something is getting deflected by electric field, this means either it is positively charged or negatively charged.
So here their focus was the constituent particle.
Yes.
Yeah, got it. Thank you.
Okay, next is, so cathode ray consists of negatively charged particle called electron. Now properties of cathode ray. They produce a green glow. I already explained you when you strike the glass wall beyond the anode. Right? Bright spot is developed when they strike to the zinc sulfide screen. I have already explained you this part. Could I move to next? Could I move to next? Yes or no? Okay, next. Next is, so here you see this is a zinc sulfide screen, the ray penetrate. Now see, he kept the one thin aluminium metal plate, and he found that this ray passed through the thin aluminium metal plate and strike to zinc sulfide screen that started glowing. This is also a proof of, let's say, you can say the ray can pass through the small metal surface. They can penetrate. This means they have a very high velocity. Got it? So electricity passes from the cathode to the anode. The small bit of electricity passes through the hole, and here it is anode. There is a coating, phosphor coating. Okay, now cathode rays are invisible. If you talk about directly the rays of cathode, they are invisible. Okay, coming to the next question. Fast. Done? What happened? Why you have not answered? Very less have answered. It is not tough question. Before that, know that cathode ray is having some velocity. Okay. So answer for this question is J.J. Thomson. Yes, next. Done. Next. Okay, correct answer for this is momentum of electron. Is it any doubt?
So why not voltage?
Yeah.
Okay. Now this is the very interesting thing. Light intensity in the cathode ray tube. Just read the answer. Momentum of electron gives the intensity of brightness of the light emitted from fluorescent screen due to electron bombardment. Momentum is needed. Okay, I told you the velocity is needed. Otherwise, intensity of light would be more if voltage is more. Do you remember I told you? You increase no matter whatever voltage you are having, it doesn't mean that only voltage is going to decide the intensity of light. Understood? Do you remember that
Sir,
fact?
but if voltage increases, then the momentum will also increase, right?
So you need to go, no, voltage increases momentum, but the best answer is momentum, right? Actually, why the light is appearing in the cathode ray when, let's say, I'm just giving you a simple example. If there is a fluorescence material, now that fluorescence material will glow only when there is a particles which will strike to it with high velocity. That fluorescence material will glow. So momentum is very much important. Understood? So now they are asking about the intensity. So intensity or brightness of light is depending on the momentum of electron due to the electron bombardment. Yes.
So if we get like multiple choice, not single choice, then can we go with voltage as well?
Yes. Then you can go for voltage.
Okay, sir.
The millikan determine the mass of the electron, right? Millikan determine the charge on electron. Mass was calculated by E by M ratio. Understood? Bombardment means electron will strike to the metals, to the zinc sulfide screen. That is called as bombardment. Understood? Yes or no? Okay. Could I move to next? Could I move to next? Fine. Next is, tell me answer of this. And guys, one more fact I want to tell you. You know this J.J. Thomson experiment or cathode ray experiment? It was not planned. It was like a surprise for them. They were doing some experiment. It was found that okay, some rays emerging from cathode and anode. It was not like it. They did this experiment to prove it. There is an electron and all. It was like a eureka type. Like, oh, what has happened? They were doing some experiment for some purpose, but this wasn't kind of accident that they got to know about electron there. Okay, now, so answer for this question is A. Fine, fast. So here the like attracts like means opposite charges have attraction, positive and negative will attract, positive and positive will repel. Next. Done. A for apple. All of you are saying A. So let us move to the answer A. Next. Please tell me the answer fast. Answer is D. So what we have discussed about the J.J. Dalton's atomic theory so far. We have discussed about the limitations. Okay. Then we discussed about the experiments, cathode ray, discovery of electron, observation, how the electron was discovered. Results, cathode ray travels in a straight line, thus produces the shadow of object. Rays rotate paddle wheel, material like paddle started rotating. Rays are invisible and negatively charged, all those things. Got it? Let us move to the next topic. Okay, I'll move to the next part of this PPT. Sadhna, oh, I might have closed that PPT. Tell me what you didn't write. I think I have closed that PPT. Should I open it again? Yes. So flow chart showing Dalton's theory. 1 minute. Okay, I will do one thing. 1 second, 1 second. I think you want just this photo, right? Okay. Next is 1 second. Okay, now we have discussed till the the atom thing. Just move to the next thing. 1 second. Just 1 second. Just 1 second. Okay, guys. So here, so far what we have discussed is the discovery of an electron. Now, what will come? Any idea? Next topic. Discovery of what? Proton. Right? Electron has been discovered here, and then neutron. So this was the discussion which we have already had this. Now we are going to discuss about the discovery of proton. So your screen is frozen for me. So here, discovery of proton. So in 1886, Goldstein repeated the experiment with discharge tube filled with a perforated cathode. Understood? Yes or no? So perforated cathode means cathode has some holes, and that cathode is perforated cathode. Understood? Yes or no? So now 1 minute. Just a minute. So here, if you see, there is a hole in cathode. So what was the story behind this? I'll tell you. See, Goldstein did what? He just thought that okay, if there is some negatively charged particle, there must be some positively charged particle, right? That positive charged particle will be the reason behind, means if atom must be electrically neutral. So discovery of negatively charged particle in atom suggested that they must contain positively charged particle also. So positive particles were also discovered in this discharge tube only. So what was done in this discharge tube? You can see here a tube. So the one scientist named Eugen Goldstein performed the discharge tube experiment with perforated cathode. Perforated cathode means this cathode is having the holes. Now what will happen? He observed a red glow behind the cathode. On this wall he observed some red glow. This means that there were rays moving in the direction. There must be some rays which will be moving in the direction from this side, left hand side, to the right hand side thing. Then only those rays pass through this holes and reported here with some color, okay, on that screen. So this ray must be opposite to that of cathode ray, and they emerges from anode to cathode. These rays were called as anode ray. Understood? Yes or no? So what will be the charge of the anode ray? What do you say? What will be the charge of anode ray based on your observation? Because cathode ray charge, you know. What is the ray charge of anode
Sir,
ray?
can you explain like how this happens?
How this happens?
So I understood like how cathode ray, the electrons will start traveling from the cathode to the
So
anode.
here the Ne plus which I drew.
Yes, sir.
This Ne plus is a part of the anode ray. So this Ne plus, let's say, present here. It will move towards the negative plate of the battery. This is the negative plate of the battery. This is the positive plate of the battery. So when they will start moving to the negative plate, some of the Ne plus will strike to the metal and stay here. But some of the Ne plus will pass through this hole and keep on going and report on this fluorescent
Okay, sir. Okay, sir. Got it.
screen. And that will give the glow. Understood? Yes or
Yes,
no?
sir. Yes, sir.
So the point is, here you have the charged particles pass through the holes and will report. So it is completely opposite to cathode ray. And this, there was a red glow observed behind that. This tells there must be some opposite charge particle. They were earlier in like the channel. Earlier the name was given like channel rays. Channel. They were like in channels. But later this name was changed to canal rays. So anode ray is also called as canal rays. Okay, I'm moving to the next. These rays were named as canal rays. Am I audible to everyone? Yes. Next is, just a minute. Let me close this. There is some problem. Okay. So here you see there is anode, there will be cathode like this. So new types of rays came out from the hole in the cathode. A faint red glow is observed on the wall behind the cathode. Since these rays originate from anode, they were called as anode ray or canal ray. Got it? Yes or no? Done? Any doubt? So since these rays originate from anode, they will be called as the anode ray or canal ray. Copied? Guys, could I move to next thing? Yes or no? Okay, first tell me, are you writing or not? Whatever I am showing you here, are you writing those things or not? I am giving you time to write only, okay? Don't skip writing. Because when you write, you understand the things. So don't skip writing at all. Yes, any doubt in this?
So can you wait? We're writing.
Now this Raghav will start writing. Right, Raghav?
No,
First,
sir. I'm in the second point.
you will know this will be the first line of today's class, right?
No, sir. I've been writing.
Sir, so it is the same experiment but reversed. Yes, but reversed. He has used his brain. Done? Now again, Goldstein did the study. All this study was done by Goldstein about this proton thing, and he called that thing as not proton thing. He called that thing as anode ray and canal ray. These all were done by Goldstein. I'm moving to the next thing. Property of anode ray. Same types of experiments were repeated what we discussed for cathode ray. You know, in the path of anode ray, one object was placed, then one pedal was placed, and it was observed the how reaction happens. So anode ray travels along a straight line. That was proved by putting the material and checking its shadow. They cast the shadow of the object placed in their path. Similarly, pedal was placed, it started rotating. So everything was done the way it was done for the anode ray. You can see the pedal thing. Vacuum pump is there to decrease the pressure. Pedal started rotating when the anode ray strikes to the pedal and reach to the cathode. Similarly, they are deflected towards the negative plate of the electric field. This shows that these rays are positively charged. Means when electric field is applied, which is perpendicular to the discharge tube, these anode ray particles diverted towards the negative plate of the applied electric field. This tells that anode ray is positively charged. Got it? Yes or no? Yes or no? Tell me first. Okay, next thing. Specific charge. So different for different gases used in the discharge tube. Specific charge is not same for all the gases. I'll explain you. First you write this. It is different for the different gases. Yes, you write it fast, then I will explain. Done. Written. Written. Done. Hey, why you are taking this much time to write one line? So it becomes lesser. So it becomes lesser as the gas atom is bigger, right? We will discuss. Okay, so E by M ratio, to understand this thing, we will write first one line in your note. Just write this one line in your notes first. What line you need to write? I will write it here. Just a minute. What one line you need to write? 1 minute. Yes. Let's say that one line is nothing but if there is an atom or molecule. So if there is an atom, now what will happen to this atom? This atom slash molecules, when interact with electric discharge, in presence of electric discharge, so I would draw some, let's say, arrow thing. So let's say, okay, fine. In presence of electric discharge, in presence of electric discharge, what will form? Electric discharge, it will form two things. Form two things. Form cation, okay? Here you have a cation, right? Cation will be going to form anode rays. Cation will be going to form anode rays. And there will be one more thing, that is anion. This anion is going to form the, not anion, you should rather write electrons, because when atom lose the electrons, then only it will form cation. Electrons will form cathode ray. This, though I already explained this by taking the example of neon, by taking the examples of neon, but you can still write this in the paragraph. Okay guys, please complete it. Write this thing fast. So why it is happening like this? I already gave you one example of neon and helium. Neon, in presence of the electron, it will lose its electron like neon plus and electron. Similarly, argon will, or let's say helium, in presence of strong voltage, will become He plus and electron. So the point is, E by M, charge is plus 1 unit in both the cases, but mass of neon is different from mass of helium. That is why denominator changes for both the things. Okay, so please write this, denominator changes though the charge remains same. Got it? It seems like no one is replying to my questions.
Yes, sir.
Sir, so protons don't constitute anode rays. No, who told you? I will tell you in which case it will be protons. As of now, I didn't tell protons constitute anode rays. As of now, I even didn't tell you that Goldstein found the protons. Goldstein just commented on the anode rays.
If you take hydrogen, it will be proton only, right?
Yes. So Goldstein just commented on the anode rays, and he spoke everything about the anode ray. Later, Rutherford came and he gave the name proton, the positive particle for the hydrogen. That name was given by Rutherford, but many textbooks doesn't consider this. They directly say Goldstein. Actually, Rutherford came later. Now, is it clear? Have you written this? Then I will dictate you something which you need to write. I hope you have written this. I'm erasing this part.
So, one minute.
Done?
So, sir, if we for any other gas other than hydrogen, we'll only get positive ions.
Yes, positive ions, not protons.
Only for hydrogen, it's protons.
Yes. We will write that. Wait. Are you done with this? Now write the next line. Particles obtained from hydrogen gas is lightest among all the positive particles obtained from different gases. These particles are called as proton, and name was given by Rutherford. Which will have the highest E by M ratio? Which gas? Which gas will have highest E by M ratio?
Hydrogen.
Huh?
Hydrogen only, sir.
Hydrogen. Because charge is same. Charge is same. Mass is minimum for hydrogen. No other atom is lighter than hydrogen. So E by M is maximum for hydrogen. Okay, now write one more line. Done? Done?
So hydrogen will have no neutron. That's why it's considered to be the proton, right?
Huh? Hydrogen is, yes, hydrogen is having no neutron. That is why it's considered like proton. Understood? Yes or no? So next line is, next I will type it here. You need to write that the same thing. What the thing? You can write it like this, like 1 minute. Just a minute. Just 1 second. Okay. What you need to write? Since we have found that the hydrogen is the lightest particle, right? So we will write these cation had an E by M ratio. These cation had an E by M ratio. E by M ratio. How much? These cation had E by M ratio. Value of nearly. How much? 1 by 1837 times 1 by 1837 of that of for an electron. Now tell me, what does this mean? Can anyone tell me what does this mean?
So can you scroll a little bit more to the left?
Fine. Yes. Anyone?
I'm on the right.
Okay. Can you tell me what does this mean? These cation had E by M ratio value nearly to 1 by 837 of that for that of an electron. What does this mean? Yes?
So
This-
shall I reply in chat or?
Okay, you can write in chat box. Yes. Sir, in the molecule there is no basic components of chemistry written. It is written as mole concept. Are they both the same in the module? Yes, mole concept is same, dear. Sir, they were those many times heavier. Very good. Guys, E by M ratio of this cation, which cation? Hydrogen cations, is nearly 1 by 8 3 times 837 times of electron, because the charge on cation and hydrogen ion charge on electron and hydrogen ion is same in magnitude, so the change is happening due to the mass. And that was the first time we got to know that mass of hydrogen ion is nearly 2000 times heavier than the mass of electron. And the interesting thing is hydrogen ion is nothing but proton, because there is no neutron. Understood? So this suggests that the mass of the hydrogen ion is nearly 183 times 37 times greater than the electron. Okay? Because cation produced by hydrogen gas is a hydrogen atom minus 1 electron. Yes or no? And it has a unit positive charge. So hydrogen has a unit positive charge. Okay, so this means hydrogen has unit positive charge. Hydrogen has unit positive charge. This means unit positive charge. This means electron. This means electron is 1837 times heavier than proton or than hydrogen ion. Understood? Yes or no? I'm moving to the next thing. Hope you understood this. So, and that time, first time, proton was discovered and the name was given by the Rutherford. The hydrogen atom is made up of one proton and one electron. So, since electron will be removed by electric discharge, this means that electron is okay. Electron is lighter. Thank you. Okay. Now, any doubt? Any doubt? I hope you understood this. Fine, because H plus is nothing but we are talking about H plus, because hydrogen atom will give H plus and electron. This H plus ion is having 1 by 1837 times heavier ratio, means its ratio is 1837 times more or less, I think. So if it is less, this means mass of hydrogen is 183 times 7 times heavier than the mass of electron, because charge is same. Because one electron is given, this means one positive will form on hydrogen. So charge is same magnitude wise. The only thing changes is m, E by m thing, that is changing. So that was the first time mass of proton was considered, and this is how the discovery of proton was done. By this, proton is over. Next is discovery of neutron. Should we take break and then continue, or should I explain you now only? Break? Okay, fine. Sir, but sir, we consider electron to mass negligible. Yes. My dear, 1837 is almost 2000 times. So when we will compare the mass of proton and electron, we will ignore the mass of electron. Means mass of atom is just a mass of proton and neutron. We don't consider electron because it is very less. But truly speaking, it is 1 by 1837 times, or it is 1837 times lighter than proton mass. Understood? Yes or no? Aditya, you need this slide? You need this? Okay, fine. So guys, with this we will have a break of 15 minutes. I will start teaching at 7, how much? 7:56 it is, right? 7:11 we will start. 7:11. Guys, audible? Now the next discovery was what to wait. Should we start now? The next discovery was discovery of neutron. Now guys, you know what happened? I'll tell you again the problem. Now this was about, let's say, after this discovery, after 20, you see the neutron was discovered in 1932. It was very late. In early 1900s, those discoveries happened. So it was around 20 years or 20-30 years. The point is, you know, it was proved that atom has electron and proton. Now Rutherford gold foil experiment also done. The gold foil experiment I will tell you in few minutes. So now it was proved that an atom has electron and proton, and few minutes back we saw that proton mass is almost 2000 times heavier than the electron mass. This means mass of an atom is because of proton, mainly proton as of now. Then hydrogen was checked, hydrogen atomic mass and the proton mass is same. So it was proved that okay, fine, hydrogen has same, means hydrogen mass is only because of proton. But now then hydrogen and helium mass was observed. Hydrogen and helium were observed when their mass was observed. Helium mass was 4 times more than hydrogen. But when proton were measured, there were just 2 protons in helium, but hydrogen has 1 proton. So according to proton, mass should be double, but mass is coming out to be 4 times heavier in case of helium. This means there must be some particle which is creating mass, and thus that particle must be neutral also, because proton and electron are equal in number. That particle should not be charged. So people were thinking, even Rutherford has an idea that, like, though he was not able to prove it, but he had an idea like there must be one type of particle present in the nucleus of an atom, but that will be a neutral atom, that will be a neutral thing. There must be some particle, but they were not able to prove it. Then the Rutherford's student only, his name was James Chadwick. He proved that there is a one particle that is called as neutron, that is present in an atom by this experiment. Which experiment? He took the alpha particles. Alpha particles is helium 2 plus ion, and the source was polonium metal. When these alpha particles were bombarded on beryllium metal surface, then the neutral particles were emitted. Those particles were called as the neutrons, and that neutron, that was the first time that neutron was discovered in the lab. So beryllium, when bombarded with helium 2 plus, you will get the carbon atom and a neutron. These notations I will tell you in few minutes. So what was the conclusion? When electrically neutral particle having a mass slightly greater than that of proton were emitted. Actually proton and neutron has almost similar mass, but who is heavier out of these two? Which particle is little heavy? Proton or neutron? Neutron is little heavy. Neutron. So these particles was named as neutrons. Guys, could I move to next slide, or you want to copy this? Have you copied this thing?
Can you explain the experiment?
Experiment is like helium particles were bombarded on the beryllium metal. So nuclear reaction happened, carbon will form, and a one particle which is emitted, 2 carbon particles will form, and the particle which was emitted is a neutron. Got it? Yes or no?
Sir, so this wasn't chemical reaction, this was nuclear reaction.
Yes. In chemical reaction, identity of metal doesn't change, or atom doesn't change. Understood? Any doubt in this? Yes or no? There were a fast moving alpha particles. When they were bombarded, these particles were emitted. Understood? So now these three particles, paraffin wax I will tell you later. The use of paraffin wax will tell you later. Now see what happened. Now three particles were discovered. Which three particles? Helium, which three particles have been discovered so far? Tell me fast. Three fundamental particles have been discovered, right? Fundamental particles means no matter whatever the gas is, these three fundamental particles, that is electron, proton and neutron. These three particles were discovered. Got it? Now, so here these are the particles. When electrically neutral particles having a mass slightly greater than that of proton were emitted, he named this particle as neutrons. Now, there must be some relationship between this electron, proton and neutron in terms of their mass. Guys, this table tells that fundamental particles will have the mass, symbol and charge. This whole thing is important. Electron, proton, neutron. If you see symbol of electron, symbol, it is little confusing for you, but you can understand it is like -1 is the charge, 0 is the mass. Mass is written on the top, charge is written on the bottom. So -1 E0, 1 H1, 0 N1, 0 at the bottom, N is the neutron, 0 is the charge on neutron, 1 is the mass of neutron. If you see, mass of neutron was exact, neutron and proton are nearly same, but neutron is little heavier than proton. Understood? Yes or no? Any doubt? Neutron is heavier than the proton. Got it? Yes, you need to copy this table fast. Then mass of electron is 9.1 into 10 power minus 31 kg. So charge of electron is minus 1.60 to 10 power minus 19 coulombs. Now that is in electrostatic unit, it is minus 4803. Proton will be exactly having the opposite charge, but unit means magnitude is same. Charge is opposite, magnitude is same, 1.6022 into 10 power minus 19 coulombs. Then neutron is neutral, so it is neutral, 0.
So should we take down all, or can we just write 9.1 into 10 to the power?
No,
minus 31?
9.1 is fine. No need to write in U. Okay, guys, if you want to know in U, just see. We have already discussed this. Gram and U relationship, you know, right? 1 gram is, okay, if you remember, 1 U into 6.022 into 10 to the power 23 is equals to 1 gram. So by using that relationship, one, if you put this kg in grams, that will be 10 power 3 into gram, and gram you can write 6.022 into 10 to the power 23. If you do this entire process, you will get this U thing. Similarly, you will get here also in terms of U, atomic mass unit. So in atomic mass unit, proton mass will come out to be 1.00727 U. This means you just write 1 U. It is almost 1 U is the mass. Similarly, the mass of neutron is 1 U, because kg has been converted into atomic mass unit. Got it, guys? This table is very important. You should understand each and everything in this table, and you should remember also. Electrostatic unit is not very important, no need to remember that, but at least coulomb, charge and masses you need to remember in U and in kg both, because you will use like thousand times at least, so you will automatically get remembered these things. But in kg, 9.1 into 10 power minus 31 kg you need to remember. Understood? So sir, if particle, sir, is new, sir, so neutron is the heaviest, right? Heaviest is, yes, it is heaviest. If a particle hits a neutron, it will deviate back. I didn't understand this point, but neutron deviate, which particle is hitting first of all, and yes, definitely, if
So like
anything,
light particle, for example.
light particle, we have not discussed the properties of light so far. Light will be hitting anything, it will deflect. Light is having a wave nature, it will deflect. Means whatever things we take, light will definitely deflect. Okay, we will discuss the properties of light in few days, means not in this class. Day after, means next class, we will discuss the properties of light, Planck's constant and all. Okay, fine. I'm moving to the next thing. Tell me answer of this fast. Fast, 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 fast. Tell me answer fast. Fast, 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 fast. Tell me answer fast. If you want, I will create link. Everyone is giving same answer. I think you people are right. Should I show you the answer? Answer is B for Bombay. Clear? Yes, no? Electron, proton, neutron were respectively discovered by. Yes, fast. Electron, proton, neutron. J.J. Thomson, Goldstein, and this. Very good. Fine. Now, next. Next. Okay, I will create a poll for this question. Fine. Fine. Tell me the answer fast. Continue. One minute. I'm not 1 minute and the poll. Relaunch. Yes. Tell me answer of this fast. All are saying B. Oh, I'm getting mixed answers. Okay, fine. Correct answer is, which is the correct answer for this question? Correct answer is, most of you are giving answer B and some are writing C. So if you want me to explain this question, then let me know. Answer is B. Sorry, C. Any doubt? Any doubt? Neutron will be 0. Electron is having the least mass. So E by M ratio will be the highest. Okay, see. E is, charge of electron is, let's say, -1. Okay, but magnitude wise it is 1 only. Magnitude wise 1 divided by 1 unit. I'm assuming, let's say 1 unit charge. I'm just assuming, like, or you can write 1.6 into 10 power minus 19 thing divided by mass of electron. Mass of electron is very small. It is, let's say, 9.1 into 10 power minus 31 kg, or I would consider it's nearly 0, means E by m is very high for electron. Let us move to the next thing. If you have a proton, charge is same 1 unit, but mass of is like mass of this is definitely huge. So it is almost 1 u mass. Here it is almost 0 in terms of u. In terms of u, it is 0.000 something u or 5 u. This is the mass. Here neutron mass is 0. Neutron charge is 0. So this is 0. So neutron will be least. Proton will be 1 unit divided by 1 u. Second number. Here 1 unit divided by 0.0005 u. It will be the highest. Got it? Yes or no? Okay, fine. One more question. Let me see whether you can answer this or not. Question is, you need to write this question. Question is, you write, here I will write, compare specific charge magnitude for, compare specific charge magnitude for alpha beta alpha particle. Here is the magnitude for electron, proton, alpha particle and neutron. Alpha particle and neutron. Now here one alpha particle has also come into the picture. Arrange them in increasing order. First, arrange them in increasing order. Tell me answer of this. Okay. Raghav, correct answer. Kaustav, think again. Saket, think again. Saket, correct answer. Sorry, yours was correct. Sorry, Saket, yours was right only. Naren, think again. Naren, correct answer. Where is alpha particle, Sadhna? Okay, fine. Very good. Arthur, correct. Aditya, think again. Okay, fine. I have given you enough time. Now I will discuss. Sadhna, think again. So how you will write? Let's say here is E, P, alpha, N. Let's say this is the order. This is the charge. Q is the charge I am assuming. M is the mass I am assuming. I need to calculate Q by M. We will see. Q of electron is, let's say, it is magnitude we will discuss, it is 1 unit magnitude. Okay, means that is the actual charge is -1 U, minus one thing. But if I assume it as 1 unit, 1 E, so this proton is also 1 E. 1 E means 1 unit. Charge of electron I am assuming E. So proton is also having the charge of electron, the same thing in magnitude wise. But alpha is helium 2 plus ion. This means 2 plus charge. So alpha will be 2E, positive 2E. Neutron is 0. Mass. Mass is almost very, if I consider this as a mass of proton as MP. So mass of electron is MP divided by 1837. MP divided by 1837. Alpha particle has total 4, 2 neutron, 2 proton. So total 4 MP. And neutron is nothing but MP. Now check the ratio. E by M ratio of all. So E by M ratio will be, Q by M ratio is 1 E divided by MP divided by 1837. So 1837 will come on top. Here it is, charge by mass is 1 E divided by MP. Here it is 2 E divided by 4 MP. That is nothing but 1 by 2 E MP. 1 by 2 E divided by MP. This is 0. So 1837 divided E by MP, 1 E by MP, 1 by 2 E, 1 by or E by 2 MP. So ratio will be E greater than P greater than alpha. Is it clear? Here EP alpha N. Got it? Yes or no? Any doubt?
So 4 MP how, sir? How is it 4 MP for
4 MP because
alpha?
there are 2 neutron, 2 proton. Neutron has
Got
almost.
it.
Okay. Any other doubt? Okay. If someone say anode ray having a ionized gas particle, is this statement right? Anode ray consists of ionized gas particle. Is this statement right? Anode ray consists of ionized gas particle. Ionized gas particle. Is this statement right? Yes, this is a right statement. Got it? Now next is, I'm moving to the next part of this.
So how, sir? Shouldn't it be specified as positive?
So ionized gas particle positive only na. So generally gas particle ionized is positive only. Means it is not electron, right? It is not proton. It is just ionized gas particle. Wherever you will get the anode ray, that will be ionized. Ionized has a further subdivision that is positive or negative ionized, but definitely ionized will be the answer. If you
Yes.
want to be very specific, you can send say positively charged ionized gas particle. Understood?
Yes, sir.
Okay. What is the basic difference between proton and neutron? It is basic difference is proton is positively charged where neutron has a no charge in it. Okay, how hydrogen atom is different from atom of other element? Fast. Write your answer. Hydrogen has no neutron, but other atom has neutron. Very good. Hydrogen just have a proton and electron. Got it? Hydrogen is not having any neutron. Please remember this. Quickly answer this fast. I'm not launching poll, just write. I want to see what is the major answers I'm getting. Okay. Everyone has given one answer, and that is A. Let us see. A is the right answer. Got it? Next question. First, done. Okay, A plus ion return. A plus ion means plus one charge. Plus one charge means charge of one proton. Charge of one proton is 1.6 into 10 power minus 19. So charge by mass ratio, you can calculate. A charge of mass ratio given, mass of atom you can calculate. Because mass divided by 1.6 into 10 power minus 19 will be 1.97 into 10 power minus 7. Everyone got the answer?
So could you repeat the numerical value for charge again?
1.6 into 10 power minus 19, it's given. In your notebook, it's written. Charge of proton and electron is same. Okay, some are getting C, some are getting D. Let us remove this confusion. I am moving to the solution. Could I move to the solution? This is the answer. Answer is D. Charge is 1.6 into 10 power minus 19. You substitute this value. Mass of neutron is very easy. A. Right. Now, atomic number of an element is Z. Mass number of an element is A. Atomic number is nothing but number of protons in any element. Atomic number is number of protons and present in the nucleus. Total number of electron present is previous question. Which question? This one. Mass of neutron is 1840 times then that the mass of electron. 1837 or 40 is almost same. Atomic number is same as the number of proton in the nucleus, and that is for a neutral atom it is number of electron also. Copied? Copy it fast. Copy it fast. Done. Okay, is it fast? Am I going fast? Some are saying no, some are saying yes. Am I going fast? No, sir, no, sir. Okay, you need to write fast. You need to write fast, that I accept. In explanation, I won't go fast in any case. Writing should be done very fast in chemistry. Because we will have a huge theory. Done? Okay, fine. So number of atomic number is the number of proton, that is equals to electron in neutral atom. And if there is a mass number is because of electron, proton and neutron. Mass number is number of proton plus neutron. Entire mass of an atom, we will neglect the mass of electron, because mass of electron is negligible as compared to mass of proton and neutron. And the number of electron is almost same as number of, or not almost, it is always, number of electron is same as number of proton, and mass of electron is very less as compared to mass of proton. So we will ignore the mass of electron. So mass number will be always equals to just proton plus neutron. Electron is excluded. Understood? Just write yes if you understood the concept. Nucleons will be proton plus neutron. One AMU is mass of one proton, that is equals to mass of one neutron. Got it? Done? Done? At least write yes, no. Okay. Atomic mass scale, 1 unit mass will be considered as 1 AMU, and as I showed you earlier in the table, 1 AMU is almost equals to mass of 1 proton. Okay, atomic number and mass number. Now guys, this is a way of representing atomic number and mass number. If some element is given, atomic number will be written at the bottom, mass number is written at the top. Okay, like helium is represented by 2He4. 2 is the atomic number, 4 is the mass number. Yes, you have done it 9th standard. That is why I am going little fast. I want to go to little fast. So, but I am not going as of now. So, but truly the mass of an atom is the mass of electron. Yes, truly means what? Yes, it is, but we ignore the mass of electron. It is like I am comparing your weight with one elephant's weight. Its weight is 2000 something, and your weight is like, let's say, just 55 kg. So if I book a truck, will I say 2055 kg capacity truck I need, or I will just say around 2000 capacity? If I book one truck to load both of you, then what do I will book? I'll book according to elephant only, na? Or I should consider you also. Okay, you're not replying. Understood? So we will ignore the mass of electron as compared to mass of proton and neutron. If their numbers were more, then we would have thought about considering its mass also. Its number is almost same than the mass of proton. I am moving to the next slide. Okay. So this, I think you can answer it. Yes, please tell me that complete this. You have just 30 seconds to finish, because these all questions you did in class 9th. calcium ion given, nitrogen atom given. Once you finish it, write done. Once you finish it, write done. Atomic number of calcium given 20. Okay, fine. So nitrogen atom, neutron 7, electron 7. Proton will be 7 because electron and proton are same. Atomic number will be 7 because proton and atomic number are same. Similarly, mass number will be 14. Here calcium ion, calcium 2 plus, means 2 electrons are less than the total number of protons. This means electron will be just 18 because calcium 2 plus. It has lost its 2 electron. So there were 20 protons earlier, 20 electrons earlier. Now they are just left 18. Protons are still 20. Mass number is 40. Got it? Got it? How many of you got all answers right? Just write me. Just write me. Only these
Sir,
many.
Na is -3, right? So shouldn't it be 10?
Which one?
Nitrogen.
They have not written nitrogen ion. They have written nitrogen atom only.
Yeah.
Okay. If they would have given nitride ion, then N3 minus. Tell me for N3 minus what will be the answer? Nitride ion. Mass number? Mass number? Fast. Nitride ion mass number? 14. Atomic number? Atomic number? Hey, how atomic number is 20? Nitride ion. Just I have added 3 electrons to nitrogen atom. Atomic number is number of protons, 7. Proton 7. Atomic number and proton will always be same. Neutron B7 because protons are 7, mass is 14, neutron is 7. Electrons will be 10. 3 extra electrons than proton. Got it? Got it? I am erasing everything. Right? Okay. So this is about, sir, what is the unit of atomic number like AMU for mass? What is the unit of atomic number? Atomic number is number only, there is no unit. Atomic number is number. How number has a unit? Understood? Representation is Z. Okay, now I am skipping these easy questions. Now what are the isotopes? We will discuss little bit about isotopes. What are isotopes? We have already learned this in class 9th. Again I am discussing the atoms of same element having same atomic number but different mass number. Any doubt in this page? In any representation of atoms? Like isotopes are represented like this. 1H1. Okay, is it right or wrong? Is this representation right or wrong? 2 at the bottom, 1 at the top. Is this right or wrong? It is a wrong representation. 2 should go on the top, 1 should be at the bottom. You can remember it like this. You know, all the atoms carry their mass on their head. You know, sara bhar sar pe. So what will happen? If whole weight will come on head, so weight will be written on the head of deuterium and atomic number will be written at the bottom. So 2D1 is the right way because atomic number or number of proton in deuterium, hydrogen and tritium is same. but their mass number are different. Got it? Got it? I am erasing this. Okay, next. Guys, so what are the different isotopes of oxygen? These are the oxygen isotopes. So how they are drawn? 16, 17, 18. These are the three isotopes. If you see, atomic number in all three are same. Just mass number is changing because number of neutrons are changed. What is difference? What is the different thing in isotopes? Proton are same in isotopes, but their neutrons will change. Just write this example of oxygen. Just write that protons are same, but neutrons are changing, so mass number is changing. Done? Done? Which previous slide? This one. Copy it fast. These are isotopes. Isotopes of hydrogen. Protium, deuterium, tritium. And this 2 should come up. This 2 should come up. Yes, I am going. Okay, fine. I think you have this deuterium and tritium representation is wrong in PPT. You can. Okay, I am going to the next slide. Okay, then. Please write this 3 isotope things. Done? Okay. Sum of the number of neutron proton is heaviest isotope of hydrogen. Fast. Fast, fast. Hey, why you are making mistake in this? Neutrons and protons in heaviest isotope of hydrogen, tritium. 1T3. How you are making mistake in this? Sum of neutron and proton is just mass number. Answer is D. Next is isobars. Isobars means having same mass number but different atoms. You can remember it isobars like in Hindi you say the word bhar. You know in Hindi bhar means weight. In Hindi bhar means weight. So iso means same, bar means bhar. It's just a way to remember. Don't write in exam. So same bhar. molecules or the atoms having same weight or same bar. That is called as isobars. This is the way to learn. You can make your own way. Isobar is having same molecular weights but different atomic number. Got it? You can see all have the top thing same. Again, it is a wrong representation here. The correct way of writing is 19K40. The 0 has come by mistake on the down. Got it? Every atom has mass 40. This is one of the potassium isotope. Generally, most common isotope of potassium has 39 weight. But this is some isotope of potassium which is having 40 mass. Normal potassium, abundant potassium or average atomic mass of potassium is 39, not 40. Got it? Yes or no? Yes or no? Yes or no? I'm moving to the next slide. Now the next heading is isoelectronic. What is isoelectronic? The atoms which has the same number of electrons. Those species are called as isoelectronic. Iso means same, electronic means same electrons. Any doubt? Now see one by one. Oxygen. Normal oxygen atom has 8 proton, 8 electron. But right now it is O2 minus. 2 minus means 2 extra electron. This means O2 minus will have same proton, 8 proton. But 2 extra electron means 10 electrons. So number of electrons in O2 minus is 10. Similarly, F minus is 10. Neon is anyways 10. Na plus, sodium, normal sodium is 11 electron, 11 proton. But Na plus, plus means 1 electron has been removed. This means 10 electron. This plus tells that 1 electron has been removed and protons are more, 1 proton is more than the total number of electrons. So this plus, this doesn't mean that something has been added to Na atom. Plus means that protons are more than electron. This means electron has been removed. You can't remove the proton because it is difficult to remove the proton from the center. No. For just for getting the electron thing you can do. If minus given, you add the electrons. Plus given, you subtract the electrons. Guys, did you understand? You need to write fast. Later you will say, sir, you didn't get time. You should be super fast in writing. Because in chemistry, this is a big problem. We have so many things to write. So your speed should be fast. Got it? Done? Could I move to next slide? Okay, next is isotone. Tone. Okay, I'll give you one trick. Isotope. Tope. Per means proton same. Isotone. Na means isotone. Neutron same. Neutron same. Isotone means neutron same. Isotope means proton same. Isobar means bar same, weight same. Isoelectronic means electron same. Tell me what is the answer here? Done? Just you subtract the mass from the proton number. You will get the neutron number. Mass number is given, proton number is given. Subtract proton number from the mass number. You will get the answer. Hope you understood this. So answer for this is what? Answer for this is C. Got it? Yes or no? 2 and 4. 77 minus 33 is equals to... No, wait. Okay, here you need to calculate isotone, neutron, same. Yes. So 77 minus 33 is 78 minus 34. Easy question. Next. Fast. Which pair is isoelectronic? Done. Isoelectronic means electron same. Argon atomic number 18, chlorine 710. Definitely not isoelectronic. Na plus and neon seems to be correct answer. We have just seen few minutes back. Answer is B for Bombay. Both has same electronic configuration. Na plus and neon. Both has 10 electrons. Yes, next. First. Done. Everyone got the answer. Answer is A for apple. Right? Isoelectronic and isotopic. Isoelectronic means same electron, definitely K plus and K plus having same electron. Isotopic, tope, means there is no need to spend the time. This is the most easiest question which I have asked. Potassium and potassium has different masses, same element means isotope. Yes, next. Fast. Some are saying D, some are saying A. How makes answer, guys? D, C, A. I got 2A. Now C. Again. A. 3A I got. I got support from A. 3 A's as of now. 4A. Okay, cyanide. Just see CO electrons. Oxygen 8 electrons, carbon 6 electron. 6, 8, 14. 14 electron you need to check. It seems A is the answer. A, I can see 14 electrons. That's it. Carbon 6, nitrogen 7. One negative charge means one extra electron. 6, 7, 1. Total 14. Got it? Got it? Yes or no? Any doubt? Now I will explain you one more important thing. The last thing of this class is Millikan's oil drop experiment. What he did in Millikan's oil drop experiment, I'll tell you in this diagram, using this diagram. So write heading Millikan's oil drop experiment. This is the experiment which was done to calculate E by M ratio of the electron. So heading is Millikan's oil drop experiment. Millikan's oil drop experiment. Okay. So what was done? Millikan's oil drop experiment. Now, try to understand what was done. There was a oil taken in this setup. You can see this setup right now in front of you. Oil was taken, and this is called as atomizer. Atomizer work is to make the small droplets of oil. So this is to oil sprayed in a fine droplet, that is the work of atomizer. Small droplets are this, oil are being made. Now here there is a positive plate of battery, means this plate and this plate are the nothing but plates of battery, or in other words these two plates were connected with a battery. Which plate? This plate and this plate. These are just two surfaces which are connected with battery. There was one hole here. So what happened? Few oil drops pass through this hole due to gravity, and it is falling down. Now what happened? See, there is a telescopic eyepiece. Means that person is observing from this end. Okay, now oil drop is falling down. From this way there is a X-ray is passed. From this path, X-ray is passed from this hole, which is striking directly to the oil surface. And X-ray is nothing but a ray of electron. X-ray is a kind of a ray of electron, so it goes like this. So electrically charged brass plates are there.
How is X-ray a ray of electron? Isn't it electromagnetic radiation?
Okay, electromagnetic radiations. Now here it is electromagnetic radiations. Okay. Now X-ray produce the charge on droplet. How it will produce charge? Okay, fine, I'll tell you. When any atom is there, what will happen? Here, if let's say there is some charge oil droplet under the observation, here it is how it is getting charged due to this X-ray. What will happen? We will try to understand. Now see, when let's say there is a one gas, there is a oil, let's say there is a oxygen gas. Here they have not mentioned, but there is a very low pressure gas is also under this. When this gas particle will strike to the X-ray, it will emit electron. This gas will emit electron. Now when this gas is emitting the electron, this electron will be taken by the oil droplets. Now observe the oil droplet. What is happening? If I have this oil droplet, around it electron will get accumulated. 1 electron, 2 electron, 3 electron, 4 electron. Right? As I told you, there is a gas particle, low pressure gas. X-ray will strike to that. Electron will be emitted. These electrons will go and stick to the oil droplet. Now this oil droplet is falling down due to gravity. But if you see, there is a positive plate of battery. So when the oil droplet is about to fall, these electrons present on the oil droplet will face electrostatic force in which direction? Any idea? Towards upward or towards downward? This oil droplet will face the force towards upward. So there is a force towards upward, that is the force due to electric field. Right? There is a downward, there is a force, that is a mg, mass of the oil droplet into gravitational force. Since the droplet is falling down there is a one more force which is acting, that is called as drag force, FD. That is a drag force. You know that when something falls down, a force is acted against its motion. That is called as drag force. So there are the three forces. Now guys, some oil droplets have one electron on it. So it will have Fe very large or Fe less if it has just one electron. If any oil droplet has just one
So
electron,
can you repeat what role oxygen and all has to play in this?
means a gas particles are there, so gas will generate a electron. This gas will help in generating electron in presence of X-rays. So when
Yes. Sir, so what will happen with that electron?
that electron will stick to the oil droplets.
Okay, sir.
So that oil droplet has the electrons on it. Now oil droplet is falling, so electron will face a force on upward direction, that is the electrostatic force. Now some oil droplet has just one electron, so what will happen? That will tend to fall down, right? Because electrostatic force is very less. But if some oil droplet has a more electrons, so force Fe will be high. So if Fe will be high, this will tend to go up. Am I right, guys? Am I right? So what happened when it was observed through the telescope in this, when it was observed through this telescope, or let's say when it was observed from here, what was seen? Like some oil droplets are falling with some speed which is very slow. Some are falling with very fast. Some oil droplets remain suspended in air. Why it remains suspended? Can anyone tell me? Some oil droplets remain suspended. Why? Because for some oil droplets, Fe plus Fd will be almost equals to gravitational force. Is it clear? Those oil droplets will remain suspended. Understood? Yes or no? And since he knows the electric field, yes, they just suspended, they just floating there only. Now, in this experiment, since he knows the electric field and he knows the electric field, and droplet of oil, mass of the oil droplet was also known, almost, density. If you know the volume, you can calculate the mass of oil droplet. If you know the mass of oil droplet, you know the drag force. I'm not going in that discussion what is the drag force and all. What he observed when he equated these forces, he observed that charge on one oil droplet, Q is the charge on oil droplet, came out to be integral multiple of 1.6 into 10 to the power minus 19 coulomb. Means some oil droplet has, this means what? This means what? I'll tell you. Let's say some oil droplet has 1.6 into 10 power minus 19 coulomb. Some oil droplet has Q2 charge, some has Q1, some has Q2 like 3.6 into 10 power minus 19 coulomb, and some oil droplet has the mass 4.8 into 10 power minus 19 coulomb. So what he observed, that all three oil droplets have one thing in common, that their charges is integral multiple of 1.6 into 10 power minus 19. This tells what? This is charge on oil droplet.
Sir, we have KVPY class from 8:15. It's already 8:07.
Just last 1 minute. So charge on oil droplet is this, and N is nothing but 1, 2, 3, and so on. So by this, just last line you write, and then I will stop class here only. The minimum unit of charge, which can be transferred is 1.6 into 10 to the power minus 19 coulomb, and that is how the one electron charge was given as 1.6 into 10 to the power minus 19 coulomb. Is it clear to everyone? Yes or no? That is how the Millikan's helped in telling the charge on electron by his Millikan oil drop experiment. Okay guys, that's all for today. Do the questions. Okay, I will share some link with you. Fine, that's all for today. If I don't share the link, you can do the questions from your module. Probably I will share the link because whatever portion we have finished, I will try to give questions from that. Thank you. Bye.
Okay, sir. Thank you.
Thank you, sir.
Yes,
Sir,
sir.
sir, so Q is the charge, right?
Yes.
So N is always whole numbers. It can never
Yes.
be in the form of fractions.
No.
Okay. Yes, sir. Okay. Thank you, sir.
Aryan done? Okay. Thank you.